Okay, limiting reactant. I want to start with an analogy, which is making a cake, because I think everybody can kind of relate to recipes and how they work. So if a cake requires 3 cups of flour and 2 eggs, now let's say I have 5 cups of flour and 5 eggs. How many cakes can I make with this amount of flour and eggs? So after the first cake, I've used 3 cups of flour, which leaves me with 2, and I've used 2 eggs, which leaves me with 3 eggs. Can I make another cake with that? No. Why not? Because I do not have enough flour. This is the limiting reactant, or in this case, the limiting ingredient. It's going to limit how many cakes you can make because you run out of it and you don't have enough to make another cake. The eggs are what's called the excess reactant, or in this case, excess ingredient, because we have some left over. Okay, so let's apply this to chemistry. Now they use reagents, and this worksheet, reagent is the same as reactant. So this video is only going to deal with how to identify which reactant is limiting. Now the key to understanding when you have a limiting reactant problem, and there's a lot of steps to this, which I'll do in future videos. I want to kind of build a foundation first of how to identify the reactant first, and then you'll figure out why we need to identify it first. When you're given both reactants, when you're given amounts of both reactants, immediately that should be giant red flag. I'm going to put a giant red flag here. Red flag, red flag, red flag. Danger, danger, danger. That should tell you that this is a limiting reactant problem, because it is 99.9999% that these amounts in like the 0.25 and the 0.4 moles, they are not going to run out at exactly the same time. So you have to identify which is the limiting reactant first. In a later video, I'll tell you why we need to do that. So 2 different ways to do this, of course, with stoichiometry. First is the long way using the conversion factors, and then second is the short way using a proportion. So I'll do the first way first. The way that you figure out which one's limiting is you pick one of the reactants. It doesn't matter which one. I can do both ways and explain why it doesn't matter which one. Pick one and calculate how many moles or grams, in this case moles, what amount of the other reactant would you need to react exactly with your chosen reactant. And I'm hoping everybody's following this along. For example, I'm going to pick aluminium. So I'm going to start with 0.25 moles of aluminium. I'm going to calculate how many moles of O2 are required to react with exactly 0.25 moles of aluminum. So in the middle, I'm going to put my mole ratio, which is 3 moles of O2 to 4 moles of Al. Cancel that. Let's bring up my calculator. So I've got 0.25 times 3 divided by 4. And to make my life easy, I'm going to make this 0.2. Go away, calculator. All right, so 0.2 moles of O2 are required. I have 0.4. So is this too much or too little? Is it the excess or is it limiting? Well, hopefully you understand numbers, you recognize that 0.4 is greater than 0.2. I have more than what is required, which means O2 is excess, which means Al is limiting, right? Okay, let's see. Let's say I chose oxygen. If I chose oxygen, 0.4 moles of O2, I calculate how many moles of Al that I need. That is 4 moles of Al over 3 moles of O2. Cancel that, calculator. Back. So now I have 0.4 times 4 divided by 3, and you see the amount required is 0.5. So you see what I mean when I say it doesn't matter which reactant you choose, because if you chose to calculate how much aluminum is required, again, this is required, to react with 0.4 moles, you get 0.5, but I only have 0.25. I literally have half the amount that I need, which means this is still limiting. Okay, last thing is proportion. I don't know if you think this is easier or not, but if you do the proportion, again, you choose one of them to calculate the other and you use your mole ratio. So 0.25 moles of Al that I'm given, I'm going to use my coefficient from my balanced equation, which is 4 moles of Al, and then I'm going to calculate for X. And at the bottom, I have 3 moles of O2. So again, back to the calculator, if I can get it up here, you're going to have 3 times 0.25 divided by 4. 3 times 0.25 divided by 4. And that gives you, this is O2, remember for O2, 0.2 moles required. Again, same thing.